in this chapter, we're going to look at risk and return from an ex ante, meaning a forecasting perspective. In the last chapter, we studied the history of the relationship between risk and return, and we saw that indeed there is a positive relationship, meaning that the higher the risk, the higher the required return. But for most investment planning problem and most investment decisions, we are looking into the future. So in this chapter, we're going to address what we expect or what we from investing in a particular project, and how does the expected return relate to the expected risk. So to address that, first we want to distinguish between expected versus unexpected return. So we know that the future seldom is exactly the same as the past. So what we will eventually get, which is the realized return, so what we actually get is typically what we expected. Life seldom happens to happen as expected. That is the same for businesses decisions and investment decisions. We did our best to determine what may happen in forming an educated expectation, but the expectation will seldom match reality. So when we look at what actually happened, this is how we use a systematic method to help us make better decisions over time. So when we look at our realized return, we look at what was expected and what was unexpected. And then we can continue to adjust our expectation the more we learn about the unexpected component. So what makes an expectation what makes an expectation a good expectation, or what makes an informed decision, is when we look at these two components, we can honestly say the following, that the unexpected component we know could be positive or negative, but then over time, the average of the unexpected component should be 0. Meaning that, so take a moment, pause, and think about why. So when we said that an expectation or a decision-making process is an informed process, or as informed as possible, is predicated on the fact that we incorporate as much information as possible in the expected component. And if the average of the expected component over time is 0, that means we have incorporated all the information that is knowable in our expectation. The part that is unexpected, sometimes over, sometimes under, either positive or negative. But if they average over time to 0, that means on average, we expect that to be 0. We cannot totally eliminate all risk, but this is really the best we can do. So now let's take a look at the risk component. So we have understand the difference between expected and expected return. Now let's take a look at the risk component. The most important concept in finance is to look at risk from a standpoint that allow us to understand the different components of risk. So just like return, we have an expected component and an expected component. There are also different components to risk. If you look at the total risk, we learned how to compute standard deviation before. The total risk is often measured as the standard deviation. So if you see the symbol, this is a symbol sigma for standard deviation. If you are investing all your money, you will be concerned with total risk. So if you're looking at the entire wealth of an investor, that investor is concerned with the total risk. And if the investor only holds one single stock, meaning she put all her eggs in one basket, the total risk of her wealth will be the same as the risk of that one stock. However, if an investor decided to diversify, meaning that she'll put her money in more than one stock, so let's say 2 stocks, then the risk of her portfolio, the portfolio will contain 2 stocks. So these 2 stocks will go into the portfolio. Then the risk of that portfolio depends on the risk of those 2 stocks and also how unexpected events affect those 2 stocks simultaneously. So the focus of this chapter is to take a look at defining risk and return, taking into account the unexpected and expected component, as well as the total risk versus interaction between underlying securities. In the last chapter, we learned how to compute average return and sample standard deviation. Those are useful sample statistics that we can use to forecast the future as well. And they are, I would say 90% of the time, they are good sample statistics to use. However, in the special circumstances where you believe that the future is going to be very different from the past, or if you have more information than just simply the past repeating the future, you can incorporate your specific information in forming your expectation. And in this chapter, we're going to look into how you can incorporate those additional information. So we'll also look at expected return, but in this case, instead of saying we expect the future return to be the same as the past average, we said we think something different is happening, and we can form a more educated guess. So in that case, we'll use a probability distribution to help us estimate future expected return. So in here, we have the probability. P stands for probability that a certain event will happen, and that the return will generate under that particular event. So let's take a look at an example. In this example, we have two possible outcomes. One is that the economy is going to go into a boom. So this is the first possible outcome. There's a 40% probability, 40% chance that this will happen. And if the economy does go into a boom, the return on our stock is going to be 30%. The second scenario is that the economy is going to go into a bust. There's a 60% chance that that will happen. And if that does happen, our stock is going to lose 10%. Our return will be a negative 10%. So we can use the formula. The formula basically is a weighted average. So what we are saying is that the expected return is a weighted average with the probability being the weight. So we have a 40% chance, so we take the probability for the first event times the expected return on the stock, which is 30%. So there's a 30% chance that the stock will return, there's a 40% chance the stock will return 30%. And then there's a 60% chance that the stock is going to lose 10%. So we can use the probability to help us fine-tune our expectation. So when we take into account the 40% chance the economy is going to be a boom and the stock will generate 30% return, a 60% chance that the economy will be a bust and the stock will lose 10%, then our overall expectation is that the stock is going to return 6%. So this is how we compute expected return. We take the probability times the return under that scenario and add up all the possible scenarios. There's one thing that you should always check. When you add up all the probability, it should sum up to 1. So that means that we have covered all the possible outcomes. Now that we know how to compute expected return, the next step is to compute risk. So we can also compute variance. And the variance follows the same theory, which is that is a deviation. So we take the event that will happen, so R is the return, minus the expected return that gives us the deviation, and then we square that deviation, and we weigh it by the probability. So, and the standard deviation is the square root of variance. So this symbol here, sigma, this symbol just means that we're going to add up. So this just means sum. So we're going to add up all the individual terms. Again, we're going to go through an example of how we compute variance. So we have computed expectation, which is 6%. Now we can compute the variance. So the variance, I'll use the symbol to save space. So similar to the expectation, we start with the probability. So the first possible outcome is that the economy will go into a boom, and there's a 40% probability that will happen. Next, we compute the deviation. So if that happens, we will get a 30% return when we're expecting, so we have to subtract the expectation, when we're expecting 6%, and we will square that deviation. So that's the first outcome. Now we have to add up all the possible outcomes. In the second outcome, we have a 60% chance of the economy going into a bust. So 60% times, again, here is the deviation. If that happens, we will lose 10% when we were expecting 6%. And again, we will square that deviation. So the first part here, 0.3 minus 0.6 give us 0.24, and we'll need to square that. And the second part is 0.6 times -1 minus 0.06, so that gives us -0.16. And once again, we will square that. And you can use your calculator to finish the calculation. That turns out to be 0.0384. So that's how you will compute variance. Again, pause the video and go through the calculation to make sure that you get the same answer. And lastly, we'll compute the standard deviation. As we see, the standard deviation is always the square root of the variance. So that makes it rather easy. So the standard deviation is simply the square root of the variance. So the square root of 0.0384 is 0.1959. And that is 19.59%. So once again, notice that we have a percentage expressed in the expected return and a percentage expressed in standard deviation. But variance does not have a unit. So now you know how to compute expected return, variance, and standard deviation. If you do not have specific information, meaning that those probabilities are not available, you have no idea what the future may hold, the best guess is to assume that the past is going to repeat into the future. So you take the average as a proxy for the expected return, and you use the standard deviation as a proxy for standard deviation. So remember that if you have specific information, if you have a better idea than just simply saying the past is going to repeat in the future, you can now have the tools to allow you to incorporate that information in forming your expectation.